Hello, my name is Doğa Demirboğa and I'm an electrical and electronics engineering student in Bilkent University. The aim of this experiment is to find the coefficients of a spring by using projectile motion. Before I start my experiment, I used a different setup to find the coefficients k in a different way so that I can compare both values and find the error percentage between them. I used the 20 grams of mass and I used a ruler to measure the spring when it's at rest and when it's compressed. And by the Hooke's law, I calculated the K approximately 200 Newton over meter. I started my own experiment. Here are the equipments I used. Firstly, the launcher. This launcher has 3 levels for the distance for the range: medium, short, and large range. I set my launcher to short range and I set my degrees up to 80 degrees. Secondly, the spring. I used a plastic wrap around the spring so that it can be attached to the ruler and at the wall at the same time. Thirdly, I used a ball with mass 96.6 grams. And lastly, I used a ruler to measure the range and the length of the compression in the spring. Here, as you can see, I start my experiment. I set the launcher to 80 degrees and I set the launcher to short range. Then I placed the ball inside the launcher and then I pulled the rope. As you can see in slow motion, the compression of the spring is 1.2 centimeters. I measured x, the range, and the mass of the ball to use these values in the needed equations. By using the range formula, Hooke's law, and energy conservation law, I find the coefficients of a spring approximately 167 Newton over meter. As we can see, there are 2 different values for the coefficient. Because of the air resistance, human-based observations, and not having an ideal lab environment, there is a 19.57% of an error occurred. Since it's hard to hit the target exactly, here are some fail videos.